During this video, we're going to take a look at solid figures, and before we go into looking at solid figures within this lesson, we're going to take a look at some key terms that we need to be able to understand and be able to have a good understanding about in order to understand this lesson. So first of all, we're going to take a look at the term polyhedron. Okay, and what that is, that's a three-dimensional solid figure with flat surfaces. Okay, so you can see the example of the cube that we have right here. That's a three-dimensional solid figure, and you can see that every part of that shape there has a flat surface. Okay, so that would be classified as a polyhedron. Now this is a little bit different from a polygon, and that polygons were two-dimensional. A polyhedron is three-dimensional. Okay, so think about these are going to be figures that you can actually hold in your hand and things like that. Okay, now within polyhedrons there are some different things that make it up. Okay, and the first thing that we're going to look at, or the first term, would be the face. Okay, and what a face is, that's a the face is a flat surface shaped like a polygon. Remember, a polygon is a closed plane figure made up of line segments. Okay, so if you see any closed plane figure made up of line segments, that would be considered a face. Okay, so you can see this yellow portion of my cube right here. That's just an example right here. That's an example of a face. It's a two-dimensional figure made up of line segments. Closed plane figure made up of line segments there. Now the next thing that we're going to look at, the next term, would be the edge. Okay, that's a line segment where two faces meet. Okay, so you can see, even though it's not shaded in, this white part right here and this yellow part right here, they meet right at this spot right here, and that would be considered an edge. Another example of an edge would be this part of my cube right there. Okay. Now the next term we're going to look at is vertex. And what a vertex is, that's the point where two edges meet, and the plural form of this is vertices. Okay, so think about just any point on a polyhedron. For example, looking at my cube, that would be considered the vertex, vertex, vertex again, vertex, and so on. So any point where two edges meet would be classified as the vertex. Plural form would be the vertices. Now we're going to take a look at naming vertices, edges, and faces for polyhedrons. Okay, and what we have here is a rectangular prism. All right, and first of all, naming the vertices. That's a pretty easy thing to do, because think about any point or any vertex on the polyhedron is labeled with a letter. So what we do is just simply write the letters down, and those are the vertices. So what we do, we can take a look at this shape. We can see we have the letter A. Whenever you're naming a vertex, you are just writing the letter, and that's it. There's not a special line or symbol that goes in front of it, like some other things that we will label throughout looking at polyhedrons. So we have the vertex of A. We can cross that out. B, and this is just simply how you do it. You just look at every single vertex and just give it the name of the letter there. C, D, cross that out. E, and it's important to cross these out, because if you don't, you'll start to get a little confused and then you may miss some. F, G, you can see this is pretty simple. I'm just crossing these out and just labeling all, or naming all the vertices within this polyhedron. And finally H. So that is how you label the vertices within a polyhedron. Okay, now we're going to take a look at how to find the edges within a polyhedron. And just remember, what an edge is, it's the line segment where two faces intersect. Okay, and that's called the edge within a polyhedron. Now, so what we can see here is I'm going to find some edges here within my shape, within my figure. So I'm going to look at the vertices of, or the vertex of A, and I can see that combining A and H, you can see that makes an edge right there. So my edge would be AH. And for edges, what I do is I will make a line right over top of that, and that's how you properly label an edge. Okay, so It's important to understand that once you use a letter, it does not mean it's eliminated like we did in finding the vertices. Also, I can see that A and B, that also makes an edge. So I will write A and B. Now, I'm still not finished with the letter A, so I can see that A and C, that also makes an edge. So I will just simply write A and C. Let me erase that really quick. So we have A and C. Once again, putting a line right over top of it, labeling it that it's an edge. If we do not put that line over top of it, then it would not be classified as an edge and we're not naming it properly. Now, I am finished with the letter A, so what I can do is just cross that out. And a way to make sure that you're hitting every single edge is by doing what I'm doing, is just kind of putting a line right over top of the edge, signifying that you've already labeled it. Now, another example of another edge would be C and D. So I will just write C, D. Also, another one with this would be C and E. So I will just write C. This will be my final one because I'm kind of running out of room here. C and E. So I would continue doing this. For example, E and F, F and G, H and G, H and E, D and F, B and D. Do not forget those ones that are in the back, and B and G. So you can see whenever I mark right over top of the edge, that'll signify to myself that I've used it already, and then I can go on and make sure I'm not missing any at all. So that's something that I would recommend you doing when you're trying to find edges within a polyhedron. Now we're going to look at how to find faces within a polyhedron. So it's important to remember the definition of a face. The flat surfaces are called faces. Okay, the outline of each face is a polygon. Remember, a polygon, closed plane figure made up of line segments. And there's not any special label for a face whenever you're dealing with a quadrilateral. However, if you're dealing with a face such as a triangle, something that has that's a polyhedron, that's a triangular prism, then you will put a special label in front of that. So think about any face that has 4 vertices, you do not need a label. Any face that has 3 vertices, you would just simply give it the label of a triangle, and then you would write, for example, A, C, D for the face. Okay, but we're not dealing with that here at all. So we're just going to simply label the face with just the 4 vertices. Okay, so we're going to take a look at this figure here and find the different faces. Alright, so I can see that the first face, I'm going to go with the top face here. It's A, C, E, H. Okay, that makes up a face right there. So I will just simply write A, C, E, H. Okay, there's not any special line or symbol or anything like that. And I do suggest you doing, once again, what I'm doing whenever you're trying to find a face, because you can get a little mixed up as you're trying to look at all the different faces within a solid figure. My next face, what I will look at, is, once again, C, D, F, and E. So C, D, F, and E. Okay, another face that I see within this solid figure, E, F, G, H. So I will write that down. E, F, G, and H. Okay, another face. I have C, A, B, D. So I'll write that. C, A, B, and D. Okay, an example of another face that I have, B, G, H, and A. B, G, H, and A. And one final face that is very easy to forget is the bottom face, which is B, D, F, and G. You can see that makes a face right there. So B, D, F, and G. Okay, now we're going to take a look at different types of solid figures. Okay, and the first one we're going to take a look at is a rectangular prism. Okay, and with a rectangular prism, it's important to understand that all the faces are rectangles. And also the definition of a prism, why is it called a prism? It's because it's a solid figure with two congruent parallel bases and faces that are parallelograms. Now it's important to understand congruent. Remember, congruent means same size and same shape. Okay, so each of these shapes here would be congruent and also parallel from each other. The next one we're going to take a look at is a cube. Okay, and a cube, what that is, we can see a cube pretty simple here, that all the faces are square. So every single face on this cube right here is a square. Okay, and so on. Now we can see a cylinder, an example of a cylinder. Okay, it's a solid figure with two circular bases that are congruent and also parallel. Okay, so right here's two circular sides there, or top and bottom there, congruent and parallel from each other. Okay, and then the final one we're going to take a look at, or another one we're going to take a look at, is a cone. It's a solid figure with one circular base. Okay, the points on this circle are joined to one point outside of the base. Okay, so you can see there are not any faces or anything like that on this cone here. What we have here is an example of a triangular prism. Why do we know that it's a triangular prism? Because the bases are congruent triangles within this shape. Now we're going to take a look at a rectangular pyramid. Okay, why is it called a rectangular pyramid? Rectangular, what that does is that signifies what the base of this shape is. It's a rectangle, and then the shape is a pyramid, so it's a rectangular pyramid. Once again, for the next shape here, triangular pyramid. Why is it called triangular pyramid? The base of this figure is a triangle. Base of this figure is a rectangle, thus the name rectangular pyramid. Base of this figure here is a triangle, thus the name triangular pyramid. Now what I want you to do is pause this video and turn your books to page 596. I want you to complete numbers 9 through 15 by yourself, and then I will show you the answers here when you're finished with this work. So you can pause this video right now. Okay, here are the answers for your work on page 596, numbers 9 through 15. For number 9, the vertices K, L, M, R, S, T. Remember, it's important as you write these down that you can just kind of cross those out. For number 10, the edges K, L, L, M, K, M, R, S, S, T, R, T, K, R, M, T, and LS. For number 11, you can see these are the faces. Now, we put this little triangle symbol here for KLM. The reason for that is because we're given the faces of a triangle. The K, use a pen here. We can see KLM. That's the face of a triangle there. So that's why we gave it that little symbol in front of it. Whenever we have a quadrilateral, for example, KMTR, we don't need to do that. Okay, so we can see the different faces. Face KLM, face RST, face KMTR, MLST, and then finally KLSR. For number 12, is a cube a rectangular prism? It is yes. I did not write the explanation. In a rectangular prism, it's important to remember all faces must be rectangles. All faces of a cube are squares, and all squares are rectangles, so a cube is also a rectangular prism. Finally, 13, 14, 15, labeling these different solid figures. What do they resemble? 13 triangular prism, 14 cylinder, and 15 rectangular prism. So that is lesson 10-1 on solid figures, and you can start working on R10-1.